By the mid-1600s, Kepler and Galileo had set the stage for the laws of science to be rewritten. But the scientific revolution was eventually ended by another scientist, Sir Isaac Newton. Newton was one of the greatest scientists ever, and he is considered to be the father of modern physics. He discovered the force of gravity, he contributed to optics, and he even invented calculus. But perhaps one of his more memorable accomplishments is his formulation of the three laws of motion. In 1687, he published these laws in his three-volume text, Principia. His laws were relatively simple, but laid the foundation for over 2 centuries of physics. So by now you might be wondering what his three laws actually state. Well, here they are. The first law says that any object will stay in a state of motion unless a force is applied. This means that if something is still, it will stay still. It won't move until a force is applied. If something is moving, it will keep moving at the same speed in the same direction until a force is applied. This law was originally stated by Galileo, and it clearly stated that a force is not needed to move something. If something is pushed, it will move forever without any more force. Of course, that was counterintuitive because here on the Earth, anything that is pushed will come to a stop. Today we know that a rolling ball or anything else stops due to the force of friction. But in the 17th century, that idea was a great leap for science. Newton's second law states that the magnitude of a force is the object's mass times the acceleration caused by that force. This means that force is only exerted if an object with mass begins to accelerate, not just if it moves at the same speed. That of course can be inferred from the first law, but this was the first time a force had been quantitatively defined. We now know that this equation is only an approximation for a more accurate equation from special relativity, but Newton's second law is accurate enough for most practical uses. Newton's third and final law is perhaps the simplest. It says that every action has an equal and opposite reaction. This simply says that every time a force is acting on an object, that object exerts an equal force in the opposite direction. For example, when you are walking, every time you take a step, you push the earth with the force, and the earth pushes you back with that same force. Now, the earth is massive, so Newton's second law tells us that its acceleration barely changes. But you, a human, are far lighter, so you accelerate forward. Your velocity was 0 before the step, but now your velocity has increased, hence you accelerate. Now, these three laws, together with the law of gravitation, can simply explain the motion of almost anything, and have been the basis for most of physics ever since they were proposed.